Welcome. Thank you for your interest in our physics department. We are excited to showcase the highlights of program and research facilities. We also want to introduce some faculty, students, and graduates.
In addition to the standard Bachelor of Arts and Bachelor of Science degrees we offer in physics, we have recently added a few applied physics tracks with different emphases. Innovation studies at Hamline started with a single course, which was the idea of Hamline alum Roger Appledorn. Roger is best known for developing the overhead projector early in his career at 3M, but he made many additional contributions to the field of optics that have significantly impacted the development of electronic devices such as laptops and cell phones. The purpose of the innovation course is to teach students about the entire process of innovation, which covers the many steps necessary to go from an original idea to a final product or implementation of that idea. Students get to learn from and interact with Roger and many other innovators from 3M and other local companies and organizations, each of whom has made a significant contribution to society through their individual innovations.
We are pleased to discuss our most recent applied physics emphasis in energy and environmental science. Students that undertake this program will learn to utilize energy resources, develop solutions for sustainability, and solve environmental issues. After obtaining a BS degree, they are prepared to continue to graduate school or to work in a number of energy-related fields. In addition to energy and environmental concerns, a rapidly growing field is in medical physics. Students interested in this area of physics will have the opportunity to work with our faculty, alumni, physicians, patients, and medical personnel. We are determining large data research regarding what is normal range of motion so that we can determine impairment ratings for those individuals who have had work-related injuries.
Hi. Here at Hamline, we have a number of astronomical and computational resources. For astronomy, we have 6 Celestron 8-inch telescopes up stairs that we can put on the roof and do astronomical observation with. We've had students do summer research with those. We have a digital camera, professional grade digital camera that we attach to the telescopes that we can take data with. And students have used that to examine, for example, looking for exoplanets around other stars and see if we can see the dimming of light. In terms of computational resources, we have a GPU cluster that can compute for AI or deep learning or simulation of physics and chemistry phenomena, material science. For example, we can calculate the bending of light around a rotating black hole and see how that actually looks like and investigate the nature of space and time around such a rotating black hole. Or we can look at how objects gravitate, hundreds of thousands of objects acting maybe individual stars or pieces of matter swirling around, forming galaxies. We can also do calculations revolving around deep learning, looking at image classification, look at analyzing networks of data and look for patterns.
Here at Hamline, we offer a number of opportunities outside the classroom for people to participate in physics-type experiences. Of course, we have a Society for Physics Students chapter, and in past years our students have taken field trips to the Sedan Mine and Fermilab. We also participate in the Minnesota Space Grant Quadcopter Challenge. We worked on that last year and we're working on that again this year. And in that, students, last year we built a quadcopter, this year we're using a prefab one. And the idea is that it's to be flown through a setup that is designed, if you have a good imagination, to resemble the surface of a different planet. And the drone is equipped with sensors to measure things like temperature and pressure and take solid samples, liquid samples, and then retrieve them. And we're doing that in conjunction with a number of other universities of the state of Minnesota. Students have a lot of opportunities to participate in projects here at Hamline.
I'd like to give a brief tour of some facilities and research projects in our department.
On the roof of Robins Science Center, where the Hamline Physics Department is located, we would like to give you a brief tour of some of our facilities, some of which are closely related to tonight's lecture.
Normally by this time of the year in Minnesota, we've had a bit of snow. Now you might ask, Josh, don't solar panels work less efficiently in snowy regions? To which I'd say yes, that's correct. However, this project aims to tackle that challenge. It's funded by a grant won in 2016 in the United States Environmental Protection Agency's People, Prosperity, and the Planet Student Design Challenge. It compares the energy output of controlled solar panel with a modified solar panel with a super hydrophobic surface. It also aims to determine which surfaces work best to remove snow from solar panels.
Hamline University has won this national award not once, but twice. The second project, winning in 2020, aims to develop affordable and reusable lead detection kits for drinking water. This research will be presented at the National Student Design Expo in the spring of 2021. These are just a few of the ways that Hamline students apply their research to real-world problems and serve the community.
Today I'll be talking to you about a project we did last year, partnered with the NASA-funded Space Grant Consortium Quadcopter Challenge. As you can see before me, this is our drone that we worked on. Essentially, we were tasked with building a drone that was basically meant to fly in a setting that we really didn't know anything about. So we had to be prepared for, there could be like radioactivity, so we needed a Geiger meter or like certain different pressures and temperatures. We had to be able to record all this data, attach it to our drone, and interpret that data in a relevant way that would be useful to us. So the drone you see before me, it's pretty far along. We have our main brain right up here that interprets all the data from our sensors. Specifically, this drone looks a lot different than when we got it. All of the propellers and everything in the way they are now, we had to solder and come up with a good way to house all of this. Down below, what we had designed was a collection arm that would extend fully, kind of like my arm like this. It would roll down like this with a simple servo motor. So that was a really cool idea I thought we had, and we were going to 3D print that to maintain a lightweight design. This year we are going to be working with this drone called the Blue Heron, but it'll be a lot of fun, and it'll be pretty similar in the sense that we will be flying in an unknown environment and trying to determine the specifics of said environment.
We also have a Magneto Optic Kerf apparatus, which is a device which is used to probe magnetic properties of materials and an external magnetic field. The apparatus was designed, ordered, and assembled by Hamline Physics majors as part of a summer research experience. This equipment utilizes several optical and electronic devices in order to measure the magnetization of a given sample. The students also developed new computational skills that allowed them to automate both the controlled variation of the external magnetic field and the measurements themselves.
The mission of the Hamline University Renewable Energy and Environmental Research Lab is to conduct cutting-edge energy and environmental research projects to develop working relationship with the industry, government, and research entity around the globe, and to share energy and environmental science and technology with the community.
We are here in the dark room. This room acts as a laboratory hood, sucking up the fumes from the liquid coatings over here and circulating in fresh air from these ceiling vents. Because we work with chemicals in here, it's really important that this room is properly ventilated.
The way we have our equipment set up here, we can deposit multiple layers on a surface.
Over here we have the spray coater. Because it is programmed by a computer, we can program it to run intricate patterns, maybe even an electronic circuit, or even a tattoo design. Over here is the thermal evaporator, and with this machine, we can fabricate aluminum silver electrodes by melting metal pellets into vapors, which are then guided to the coated material. An important function of these facilities is that they allow us to create flexible, multi-layered electronic devices. Because these machines don't require high temperatures to function, we can use thin and flexible materials such as paper, glass, and plastic.
Imagine a patch on your palm that can monitor your heartbeat or vitals, or a prosthesis that can simulate the sense of touch with electronic skin. Have you ever noticed the way butterfly wings change color depending on your viewing angle? Or maybe you really admire the iridescence of opal. What you're observing in these instances are natural examples of photonic crystals. These are complex, multidimensional structures that tailor the color or direction of light that enter them. We model these structures for fabrication, which we do with lasers and light-sensitive chemicals. These models allow us to tune these structures to change or absorb the light that enter them. The first beam here is split up into 4 different paths which hit the structure on different sides. When the light comes in contact with the surface, it creates patterns of light and dark spots through photolithography processes. We use these structures in research projects related to solar cells, but they are also used in decorative paints, which may only give off color in a particular light or angle.
When you think of a solar cell, what comes to mind? Probably something along the lines of a large rectangular blue in color panel that you would see in a large field or on the top of your neighbor's home. These are silicon-based and made with silicon cells. Some of our research here at Hamline has been dedicated to the exploration of natural dye alternatives for these cells, where we test the efficiency of different types of natural dyes. Some of them include blue pea, raspberries, turmeric, cherries, blackberries, passion tea, or even spinach. Hey, if you don't want to eat it, we'll gladly use it for our research. The process that is going on here, essentially, when light hits the dye molecules, electrons are released, a similar process to photosynthesis. Beside me is our sun simulator. We use it to test our cells under specific solar conditions, to test the effectiveness and the efficiency of each individual cell.
In here, we can fabricate and test batteries and supercapacitors. We use this Glovebox Station to assemble coin-type lithium-ion batteries with liquid electrolytes. If we built these in the open air, lithium can easily react with oxygen and water moisture. So this station is useful because it best provides a stable, argon-filled, moistureless environment in which we can assemble this type of battery. We can test lithium-ion batteries and supercapacitors using these instruments to guide our experiments. In addition to research, you could also use these batteries and capacitors to power a device or vehicle in an engineering project.
We also have built solid-state thin-film lithium-ion batteries, which have solid electrolytes rather than liquid electrolytes. These have important potential applications for wearable electronics, implant medical devices, and smart cards. We could build them in our vacuum chambers, which use physical deposition methods called sputtering and thermal evaporation to transfer materials from a target to a substrate.
We are very excited to talk about our brand new Environmental Scanning Electron Microscope, or SEM. This instrument has a much higher resolution than an optical microscope, using electron beams to analyze minuscule samples. Different signals generated by electron beams are processed via different detectors, and these are to provide high-resolution images and compositional analysis of the samples.
The lateral resolution is 3 nanometers. 1 nanometer is 1,000th of 1 micrometer, and a human hair is dimensioned in the tens of micrometers. Its potential for analysis means that it can be applied to any number of fields beyond just physics. It could be used in forensics, examining gunshot residue, comparing hair fibers, or in toxicology. What's more is that you can use this environmental SEM to examine fresh organic samples such as leaves, flower petals, and butterfly wings in their natural state without coating an electrical conducting film. It can also be applied in material science research to discover new materials in the fields of pharmacology and semiconductors, as well as to optimize manufacturing processes through device failure analysis.
These facilities and equipment are just a few of the ways that alumni give back to our department. Here is what some of them shared about how our program prepared them for success.
My technical career was at 3M for about 33 years, I guess. And Hamline really prepared me well. It gave me a physics education and soft science education, if you will. So sociology, anthropology, psychology, and in many cases, as you move up the technical ladder, the leadership requirements grow through time, and those soft sciences really prepared me well to be a leader and know how to lead and stuff. Physics-related programs, I designed integrated circuits, I worked on touch screens, I worked on a fair number of electronic products, I worked on high-temperature fluid modeling, so it really helped me well. There's no way one education of 4 years can prepare you for 30-some years of work. So you have to know how to teach yourself. And that's really what I came out of Hamline, with a very strong ability to ask the right questions and then walk myself through how to find those answers. Hamline's done me a great job, and I think they do well with you. Thank you.
So I'm here today to tell you about the value of coming to Hamline University, what you'll find there, and what you need to be looking for to be successful and have the best experience of your life. My time in physics is among some of the most formative experiences at Hamline University. I formed relationships, I had opportunities, I had great success, and of course, some failure as well, which is important in growing and learning at any academic institution. But really what sets Hamline apart is being able to form those relationships and have this unique environment for learning. Because still 30 years later, I'm interacting with the staff and faculty there, I'm working with students in research, and I'm just having a great time, and Hamline simply became embedded into my life. What we want you to experience when you come to Hamline University is a sense of excitement, doing everything you want to do, meeting people, changing the way you think, and changing the person that you ultimately will become. So at Hamline, you're going to learn that we have values. We want people to do great things with great people and give back to the university throughout the course of your lifetime and professional experience. I hope this is helpful, and I really hope to see you at Hamline University.
Hey guys. So one of the best things about being a Hamline physics major was the advertisement that I actually got of you can actually go on and do anything you want in the world. Because with the physics major, you're able to solve any type of problem you can face. Whether or not you know how to do it, you actually learn the methodology for how to solve problems and can move on from there. One of the best parts of it was actually celebrating the professors' birthdays and arranging stuff with their spouses ahead of time so that the professor was actually still surprised by it.
The Hamline Physics program to me is unique and excellent because of the small class sizes and because of the access that you have to professors who are always willing to come talk to you and help, whether it's with coursework or just navigating your way through the process of earning a degree. I had lots of highlights in my time at Hamline. Really loved living at the dorms and getting to know some of the people that became my best friends for many years afterwards. Hamline did help prepare me for my career, my undergrad education. You know, not always the specific things you learn in classes, but learning how to be a problem solver and how to accomplish tasks and figure out things to help run a successful project were what I learned in the physics program at Hamline. I've been lucky enough in my career to work on many projects, and one that stands out that was physics related was developing new touch sensor technology to help make sensors for your phones and computers that are more accurate and can work in all kinds of different environments.
I think the biggest thing that made the Hamline Physics experience unique was the people. Not only the students who you will get to learn alongside, you will get to know well, and you will really hopefully become good friends with for life, but the professors as well. The professors are really invested in your development, in giving you advice on future career paths, grad school paths, and the like, but also make a very warm and inviting environment. One example was one of my first classes at Hamline was with Dr. Kevin Stanley, and one of the first days I went up and addressed him as Dr. Stanley, and the first thing he says to me is, "Actually, Kevin is the thing to call me." So just again, a microcosm of how Hamline professors really care about you and want to sort of develop a good relationship beyond just a typical professor-student relationship. I think the biggest highlight of my experience at Hamline was the fact that I could not only study physics, but also business and participate in 2 sports at Hamline as well. That's something that I think Hamline allows, but not necessarily is going to be possible at any school that you go to. And that was one of the big contributing factors in my decision to go to Hamline personally. I think also Hamline does a fantastic job of preparing you for whether you want to go to grad school, whether you want to start your career, or some combination thereof. I personally went on to study automotive engineering and get my master's in automotive engineering, and I currently work at BMW in Spartanburg, South Carolina, and I think my Hamline physics education gave me a great technical background to be able to translate into a master's in automotive engineering, but I think it's also great and it can help you in any field you want to study. So I think that's a big positive thing that Hamline can bring to the table.
One example of something that I took from Dr. Jerry Artz's class was that he has taken very meticulous notes, and he would photocopy all those notes and he would provide them to his students. And there was one instance from electromagnetics where we actually found a solution for a wave equation in boundary conditions. And the solution required us to do separation of variables method. And so I took a theoretical acoustics class in about my 3rd year, and we had the wave equation solved in the ocean. And the solution was found by separation of variables method. So I got so excited when our professor proposed or showed us this equation, and I ran home and I dug through my closet to find my binder of notes that I still had from Dr. Artz's class. And then I took it back and told all my classmates the secret to separation of variables. So that was very exciting. I also took differential equations in undergrad with Bruce Bolin. And then I had to take the same or a step up from that in graduate school. And so I remembered most of what I learned from Bruce's class for PDEs and ODEs. And then that class was pretty fun and easy for me in graduate school. So some cool things that I've got to do because I'm in oceanography and also ocean acoustics is since I went to graduate school, I got to go on a ship and do an experiment. I get to study, I've studied sound in the Arctic, and I've looked at sea ice and all of that. I've also got to go to Hawaii for some research on coral reefs. But actually one thing I really love is computer coding, and I do a lot of machine learning. And one thing that really got me forward in that is Andy Runquist was very into coding, and he made us all do Mathematica. And I became kind of like a whiz in Mathematica, maybe not, but I loved Mathematica. And so when I got to graduate school, I actually had to use MATLAB, and I never had used that before, but I was actually able to teach myself based on everything I had learned at Hamline. And from there have also learned Python too. So yeah, I learned a lot in my undergraduate experience at Hamline, in the Hamline Physics department, and I think that it really stands out because of all the interest and effort that the faculty puts into every one of the students that goes through there. I think it's a really worthwhile experience for anybody who's considering physics programs that you should really consider Hamline, because not only will you get a good education that can take you really far, but you'll also get a lot of personal attention and personal growth that you can take with you through the rest of your career.
The physics department is very fortunate to have many generous donors. There are a number of scholarships and awards for our students that allow us to recruit and educate some of the best and brightest students. Some students would have never been able to afford to come to Hamline were it not for your generous donations. Thank you ever so much for all that you have done. And especially as of late, we wish to give a special thank you to those of you who have provided the funds that have allowed us to purchase a state-of-the-art environmental scanning electron microscope. This will provide a research and learning experience for not only students in physics, but also for all departments at Hamline campus-wide.
If you have any questions or need more information about our department, facilities, research opportunities, and much more, please contact us or visit our website. Thank you.